Welcome to second year engineering computer graphics subject, unit 5, lecture 2. I am Dr. S.N.Gujar. I am working as a professor in Department of Computer Engineering, TSSM, Bhirabai Sawant College of Engineering and Research, Nare, Pune. Today we are going to learn the unit number 5, that is the shading, color models and the animations. The second part, in the first part I have already covered there about the RGB color model and CMYK color models. Now the second part is going to start from the CMYK color model. So basic RGB color model that is going to reverse over there is the CMYK color model. Cyan, magenta and yellow. K stand for the black colors over there. Now the black colors is going to come here top and then white colors at the bottom, and then here the blue in a RGB color model, suppose that is on the x-axis, so here become a cyan on a x-axis. Like same way the magenta on y-axis and then yellow is on a z-axis. So in between there the RGB color model. So red in between the magenta and yellow, cyan and yellow is the green color, and then cyan and the magenta is the blue color. Now here again the grayscales are there. The grayscale is going to vary the color combinations from the black to white. So that's why I represented here in the dotted. Now primary colors are cyan, magenta and yellow. So principal axis, that is XYZ, and then a map with the CMY. Useful for the color output is for the printer. So cyan blue plus green, that is become the red absorbed there. Magenta is equal to blue plus red, that absorbed with the green. Yellow, so green plus red, subtract blue. Now whenever the basic use of the CMYK color model is for the your color printer. Now if defining a color with subtract process inside the unit cube, white is at the origin 000, see the origin 00 is the white, that's why it is the coordinate become x is equal to 0, y is equal to 0, z is equal to 0. Black is on the top, that is a 1 1 1, because all the components of the incident lights are subtracted, green 101, cyan plus yellow, so that's why it become a black on the font. Now usually the primary printers with the CMY model uses the 4 colors in a generation of the color point with the collections of the 4 ink dots, cyan, magenta and yellow, and the black is going to add over there for the black and white. The combinations are there. The black, because combinations of these 3 CMY produce the dark gray, not black. Okay. Now come for how this is going to calculate. So that is the form of the mathematically. If we assume the cyan, magenta and the yellow color is the subtracted components of the red, green and blue, then we can represent this relationships as C is equal to 1 minus R, because the 1 we have considered for the black. Here don't you have to consider the 1 as in white. Okay. M is equal to 1 minus G, so that is the black I am going to subtract it from the green, that is why the magenta is going to come over there. Y is equal to 1 minus B. So CMY we represent in the matrix form. So RGB 111 minus CMY. So where black is represented as a unit columns vectors in the CMY, cyan, magenta, yellow, and RGB represented with the matrix. So where white is represented as a unit column vector RGB. So see the both color model at one time. So here black is our basic color 0 0 0, and white is our top color 1 1 1. So that's why this red, green, blue combinations are going to form from the RGB. Now similar way CMY, white is on the top and black at the bottom. Okay. So we are going to subtract this black. So that's why CMY, cyan, magenta and yellow. So this is the cyan color, magenta color and yellow color. So these are the combinations that are going to form, and then we are going to add this K colors over there, that is for the black. So this is the comparative statement of the RGB and CMY. Now next is the HSV color model. So whenever at the top, that is going to form hexagonal, and that hexagonal you have to consider over there for the HSV. So H stand for hue, saturation, and V stand for value. S stand for saturation. Now it uses the color description instead of the set of color primaries. So H, hue, saturation and values are used to indicate the color. H, hue is equal to pure colors of light, means I am going to focus on the lights over there, and saturation, how much the white light is mixed with this color, and V stand for the value. So HSV color model represented is derived from the RGB color model. So basic is our RGB, from that we have derived the HSV. Now how? So if we imagine weaving the cube along with the diagonal form of the white vertex to the origin, that is the black color, see the outlines of the cube has a hexagonal step. So this is the hexagonal step that is going to form from the RGB and CMYK color model. So RGB color cube, and then the color hexagon is coming in between this, so that is the RGB and CMYK, both the combination we are going to put over here. Now how the HSV color border is going to form from this hexagon? So that hexagon center point we are going to trace with the bottom, and all the lines are going to put. So this is the dotted line is the hide lines, and this is the complete line is the in front of line. So in the hexagon, the saturation is the measures along horizontal axis, and the value is measured along with the vertical axis through center of hexagon. Now here is represented as an angle about the vertical axis from 0 degree at the rate through the 360 degree. So that is going to vary the H value, U value. Vertices are separated at the 60 degree intervals. Okay, yellow is at the 60 degree, green is at the 120 degree, and cyan is at the 180 degree. So that is going to complete our complete 360 degree. So how is going to represent it? This is the diagram you have to draw at the time of examinations. For the hexagon you have to draw and then trace over here. See the angles I am going to put 0, 120 and 240. Okay, so for the hue, and then RGB color, V for the value, and here V is 0 you have to put, H is the angle of the hue angle, and saturation yes you have to put over here. So this become a HSV color model. Now you shift the colors of all pixels clockwise or the counterclockwise, that may be say as an anti-clockwise, about the color field. Saturation increases or decreases the color saturations fully in saturated colors and bright, while low saturations are grayish. Lightness increase or decrease the lightness 0. Lightness results in a black all black pixels, and while full lightness with the white. So now how this colors addition and the subtractions is going to use in a color images or color photos are there. So this is the combination I am going to put. See, so this is a variation from RGB through CMY. Here plus I am going to put for the additions, and in the minus I have to put for the subtraction. Now I have subtracted this color from the basic color, because you cannot say that which is the best diagram over there, because of I am going to add some. So the saturation, what is the saturation means addition and subtraction. Slider increases or decreases in the intensity of the colors. So lightness slide controls how light or dark, means I am going to start from the black to white, and here I am going to do the saturations on this image. So how the image is going to changes, make the changes over there for the degrees value. See 0, 60, 120, 180 in the bracket I have put, that is the degree value for the saturation, and here I am going to put the lightness over there. So HSV color model saturations varies from the 0 to 1, values are also 0 to 1. When V is equal to 0 indicates the black, when V is equal to 1 indicates the white. At the top of the hexagon the colors have a maximum intensity, and hue select is done. The H is with yes and 1 V is equal to 1 value. Now the next color model is the HLS color model. So here lightness are going to increase from black to white. Here where the hexagonal dimension you are going to form, here comes to the bottom also, and here comes to the bottom top also. How the variation of HSV model is called as HLS color model. So use light and saturation. PL stand for lightness. It is generated by the deforming the hex cone of HSV model by stretching the white point along the value axis. It looks like two hexagons are placed, so black to the black, okay, back, and back to the back. Means back to the back means this is the back side of the, this is back side of the apex, and the white other apex. In HLS model, white has lightness of 1 and the black has a 0. Fully saturated color have a lightness 0.5. So this diagram also you have to draw in examination. Now the HLS color model, HSV and HLS models are useful in implementing programs where the user must select the color. It is not always easy to tell which RGB values are needed to get the desired color. we might allow the users to specify color using the HSV model and then they convert it into RGB display. Now YIQ color model. Okay, so this comes the YIQ color model is luminance information of the content is called as the Y parameters are there. So why? So luminosity information U and the purity is incorporated into the I and Q parameter. Since Y contains luminance informations, black and white TV monitors uses only the Y signals. A color TV would take these three channels YIQ and the map with the information with the black RGB levels are like this going. So these are the standard format they are going to use. These the values are going to use for the YIQ color model. Convert from the YIQ to RGB in RGB to YIQ color model. So that you have to multiply with the RGB with these factors. So YIQ going to form, and now suppose you multiply with this factor with the YIQ, then RGB colors are going to form. So how this is going to represented in the black and white and in the color formations is there. That is the one image I am going to display. Or luminance is the brightness, the intensity of the light emitted from the surface per unit area in green directions. Use shades and the advantages are there. In the model, that more bandwidth can be assigned to the Y components luminance, to which the human's eye is more sensible than to a color information used by the color TV. The computer animations, the next point is the computer animation is the start from the art, that is the creating, moving the images via the use of the computer. Basic definition, computer animation means what? Art of creating moving images by using the computer. Application of the computer animations, entertainment, computer games, cartoons and advertising, scientific and engineering studies also, training and education. So these are the some applications that are going to use the animations. Animation sequence is designed with the following sequence. What are the sequences are there? First one is the storyboard layout, object definitions, keyframe specifications and generations of in between frames. So this is nothing but all generation of the frames. So in 1 second means that's need the 1024 frames. Now what is the storyboard? Storyboard means what you want to draw. What is your story you are going to draw over there? A series of sketches or photographs showing the sequence or shots or images planned for a film is the one of the basic definition of the storyboard or layout. It is the outline of the actions and set the basic events that are to take place in a specific order. It gives the motion sequence and it consists of the rough sketches. Suppose I am going to put the bouncing one ball. So see the images are going to start from this basic. Suppose this is the basic images I am going to put in between the combinations. Okay, so then I am going to repeat it this 6 frame continuously. So suppose I am going to repeat it this 6 frame continuously up to 1 second. We have repeated the 1024 frame. So that look like a bouncing ball like this. Is it? Now second one, object definition. In the object definitions given for each particular in the actions, meaning for definition, and different object you can put on the one storyboard. Each active section and the trade as an object. It is defined as the term of the basic shapes such as the polygon. Okay, along with the object, motions associated with the object is called as the define. And then keyframe specification. Keyframe is detailed drawings the scenes at creating time of animation sequences. They are positions according to time of the frame, and in between frames you can add in between this there. So these are the intermediate frames between the keyframes. Usually there are the 3 to 5 in between frames you can add. So film requires for 24 frames per second. Okay, so this is the use of our. Now this is going to complete our computer animation.